Good morning, dear students. Last session we have talked about the high strength steel, where types of prestressing steels, forms of prestressing steels we have talked about, uh, and the properties required for high strength steel. Okay. Uh, Today we'll look at it, the strength of prestressing steel. Let us see. So, unlike your HYSD bars, we have uh, testing procedures for this wires also. So that is by the IS 1521 method for tensile testing steel wires. It's like almost very similar to the usual tensile test by UTM that we have in now undergraduate. So tensile strength of pre-stressing steel is given in terms of characteristic tensile strength. So we talk about the strength of pre-stressing steel is like just like concrete characteristic compressive strength. So similar way, we talk about characteristic tensile strength. Okay, and this is defined as the ultimate tensile strength of the coupon specimen, which we call it the wire specimen, below which not more than 5% of test results are expected to fall. The same acceptance criteria, whatever is used for the concrete, is same as it is for steel also. Even concrete also, we said acceptance criteria. If you test some 100 specimens, out of 100 specimens, 5 specimens should not the test results. I mean, compressive strength of 5 specimens shall not more than 5 specimens shall not fall uh, below that value of compressive strength that you require, right? Same acceptance criteria is followed for steel also, that is 5% specimens. Okay, and to test the tensile strength of wire, so we use a specimen called Copen specimen in the testing machine, and this is the test setup. So as I said, very similar to that of UTM, but you don't find such holding cups, wedge grips in the uh, UTM. So this is the specimen, and this is extensometer to measure the elongation, and these are the grips that wedge grips that are to be used to hold the specimen. And this you can see after failure of the strand, that you can see that failure of strand is given here, right? Right, in open your IS codes, look for 5.6.1.1 class, okay, IS 1343 1980 has given the high tensile steel bars. The relevant IS code is 2090. Minimum tensile strength is 980 Newton per mm square for high tensile steel bars. Okay, and proof stress should not be less than 80% of the specified tensile strength. You know what is proof stress from your strength of materials. So it is the stress at 0.2% strain, right? It is what is called the proof stress, which is also defined by the IS codes. Okay. So proof stress should not be less than 80% of the specified tensile strength. Okay. And the minimum tensile strength for this is about steel bar, what we talk about. We have different forms also, wires, strands, like, okay. So we will see the tensile strength for different types of wires. as specified by the respective codes. Each one will have their own code. Like steel bar, it has IS 2090. Similarly, there are other types like cold drawn stress relieved wires, which has IS 1785 Part 1, where minimum tensile strength for each dia is given in that IS code. So 2.5 mm, it is 2010 megapascal, and 3 mm, 4 mm. Likewise, till 8 mm wire, the strengths are given. Again, the same condition holds good. When you test these bars of specimens, the proof stress should not be less than 80% of the specified tensile strength. I mean, this is the specified tensile strength value. So when you test a bar, the sample, so it shall not be less than 85% of this value, the proof stress value. Okay, right. Similarly, other wires, as drawn wire, which is part 2 of the code, which is available in only these 3 dias, and proof stress should not be less than 75%, and indented wires IS code is 6003, and the respective dias available are these, and similarly proof stress should not be less than 85% of the specified tensile strength value. Okay, and these are some of the uh, properties of uncoated stress relieved strands also. Strands. Till now we have talked about wires. These are strands like 2 ply, 2 mm, and 2 ply, 3 mm. What does this mean? 3 ply, 3 mm. So 2 ply means there will be wires of 2 mm, and 2 ply 3 mm means 2 wires of 3 mm. 3 ply means there will be 3 wires of, 3 mm, that consists of this. 7 ply, okay. So central wire, and then surrounding that there will be 7 wires, 6 wires surrounding the central wire, okay. So this is like 7 ply, okay, of so and so dia, right? So these are the properties, different properties. Uh, no? Like, so breaking load is also being mentioned in that IS code. So IS 6006 will give you that properties of this strands. All these are strands, okay. So 2 or more wires, or 2, 3, 7 wires will be spun together to form a strand, okay. So that is another type of another form of steel. Okay, so that's about the strength values, like how much should be the tensile strength of the wire for different categories of, and how do you test it, and how do you accept the steel that you bought. Okay, right. Coming to stiffness of prestressing steel, which is given in IS code IS 1343 2012 class 5623, says that modulus of elasticity of untensioned steel, means nominal steel bars, not high strength steel, shall be taken as 200 kilonewton per mm square, and the stiffness of pre-stressing steel is given by the initial modulus of elasticity, that is the one which is mentioned in the code, and modulus of elasticity depends on the form of pre-stressing steel, whether it is wire, strand, or bar, whatever it is. Okay, so this earlier IS code specifies these values, but the code which is modified in 2012 will be different on this one. I'll show you that also. we'll discuss in detail. So the Young's modulus is changing with the type of steel, okay, right? Whereas for untensioned steel like HOSD bars, it is same as 200. Okay, and this is what the clause on mechanical properties of prestressing steel given. Like that is what I was telling. The 2012 change in 2012. This was earlier code given. Okay, now the code has been changed. So what it is telling? You see, shall necessarily be obtained from manufacturer. Okay, code doesn't say this is the Young's modulus value. So data in respect of modulus of elasticity, even relaxation of loss at 1000 hours, at a mean temperature of 20 degrees, minimum ultimate tensile strength, stress strain curve, everything, stress, etc. All the mechanical properties shall necessarily be obtained from manufacturer. Okay, and pre-stressing steel shall be subjected to acceptance test prior to actual use on the works. I mean acceptance criteria which we were discussing, like 5% of the specimens, a result of them shall not fall uh, below the respective strength value, right? So that acceptance criteria shall be adopted, and modulus of elasticity value as per acceptance test shall conform to the design values, which shall be within the range not more than 2.5% between maximum and minimum value. Okay. So this is about modulus of elasticity. So as the earlier code has given some values for different types of steels, but the latest code on restressed concrete 134.32012 has given clearly that you shall obtain from manufacturer all the properties, and also before you use you shall test it for acceptance, okay, for its acceptance, and shall see that the design values shall be within the range of 2.5% between maximum and minimum. Okay, so that is about the strength properties of steel. Okay, so clear. The strength properties shall be obtained from the manufacturer itself. Okay, and you have testing procedures like the normal UTM. It's very similar to it, but it's different setup. Okay, and for different category of forms of steels, we have different IS codes mentioned here. For bars, it is 2090, and for cold drawn stress relieved wires, it is 1785 part 1. As drawn wires, it is part 2. Indented wires, it is 6003, and whereas for strands, it is 6006. Okay, and for Young's modulus, we need to follow the strictly manufacturer. All for all those cases, whatever are given, the mechanical properties, all the mechanical properties, modulus of elasticity, relaxation loss, ultimate tensile strength, stress strain curve, etc. Everything shall be obtained from the manufacturer, and once you obtain from the manufacturer, shall be cross-checked again by the acceptance test. Okay, you do the test, relaxation test, and modulus of elasticity test, tensile strength test, likewise stress strain curve. You just clarify, I mean, whether it is within the permissible limits or not. Okay, it is 2.5% between maximum and minimum values for uh, the samples that you take. Okay, right. We'll discuss the further topics in the next session, like permissible stresses in steel. Right. Thank you.